So we're going to get started on day 3 of the solids unit, which is going to talk about congruent and similar solids. We talked about congruent and similar triangles before, so this shouldn't be all new to you. First off, we want to define similar solids. We should remember what similar triangles were. Similar triangles had exactly the same angles and shape, but they didn't have the same side lengths. The side lengths were in proportion. So what we want to fill in here is that solids that have exactly the same shape but not necessarily the same size are similar. And just like congruent triangles that had exactly the same size and side lengths and shape, we're going to say that congruent solids have exactly the same size, exactly the same shape, and exactly the same size. So we need to determine whether each pair of solids is similar, congruent, or neither. So we're going to find ratios to determine that. So the first shape we have is a pyramid. We're going to take a look at the lengths here. So we're going to have 6 over 3, and we want to see if that's equal to 10 over 5, and if that's equal to the height of the pyramid, which is 8 over 4. And we see that all of those are 2 over 1. So that means that the pyramids are similar solids. Whenever we have a constant ratio, that means they're similar. So to kind of speed you along with number 2, you might initially think that they are not similar, but you should see that the diameter is 36. So whenever we make those same fractions, we see that they are similar, and the ratio is 1 to 4. Another way of writing a ratio is 1 colon 4. Remember, this means 1 to 4. For number 3, I do have solids. It's not one of the shapes that are on my formula sheets. It's a composite shape. But if I want to compare the side lengths, I see I would have 6 over 6 is equal to 2 over 2, which is equal to 7 over 7. And let's see, for some reason I wrote a 2, which is equal to 2 over 2. And since these are all equal, we have a ratio of 1 over 1 for each of them. That means they are congruent. An example of solids that are neither congruent or similar can be found in number 4. We have heights of 5 and 10, and we see that this is not equal to the radii of 2 over 2. So that's neither. Hopefully you remember this symbol means congruent, or we use that symbol for similar. So the equal sign with the tilde on top was congruent, and just the tilde was similar. We have a very important theorem about solids, and we're going to show you this with an example on the next page. If two similar solids have a scale factor of a to b, then the ratio of their areas is a squared to b squared. So we're going to be talking about surface area primarily. Lateral area is something we've also mentioned in class. And their volumes will be a cubed to b cubed. The best way to remember this is to think of what units you have whenever you find area. You have squared units, you have centimeters squared. And what units we have for volume. We have cubic units like centimeters cubed. So let's do an example here. It says 2 different sized balloons are being used to decorate for a party. When fully inflated, the balloons are spheres. The larger has a radius of 18 inches, and the smaller has a radius of 8 inches. So let's find the scale factor of the balloons. So all we do is we're going to do 18 divided by 8. We simplify that, it's going to be 9 over 4. We're also asked to find the ratio of the surface areas of the balloons. So that's where we're going to use this theorem up here, where we have a squared to b squared. So we're going to have 9 squared because we're doing area over 4 squared. It's going to be 81 over 16. We also are asked to find the ratios of the volumes. So that means we're going to cube it. So we're going to have 9 cubed over 4 cubed. And this comes out to 729 over 64. That's all you have to do with those. We'll be doing more examples on pages 2 and 3. So if I want to fill this out, this chart here, we want to find the ratios of similar figures in solids. So we have square A where the length and sides are going to be 2 units. So that means the perimeter is going to be 4 times 2. I'm using this formula up here, which is 8. The area is going to be 2 times 2, which is 4. And the volume is going to be 2 times 2 times 2, which is 8. So the other one, which is 3 units, I'm going to have 4 times 3. Again, I'm just substituting in for these formulas here. 3 times 3 is 9. And the volume is going to be 3 times 3 times 3, which is 27. So we're asked to write ratios. The first ratio deals with just the side lengths. That's in our first column here. So it's going to be 2 over 3, or 3 over 2 whenever we put square A over or square B over square A. For the perimeters, we're going to have 8 over 12, which simplifies to 2 over 3, and 12 over 8, which simplifies to 3 over 2. For the areas, we're going to have 4 over 9, or 9 over 4. Those will not simplify. And lastly, for the volumes, we're going to have 8 over 27 and 27 over 8. So whenever we look at this data, we should be able to find patterns. The ratio of any two lengths is A to B. Remember, we can also write that A to B with a colon in the middle. The perimeters are the same, A to B. The areas are going to be 2 squared over 3 squared, so that is squared. Again, this is the same as our theorem as before, which also mentioned that the volume was A cubed to B cubed. So if I go back to my first page, I see that theorem right there again. This is where I took some data and I used squares with different side lengths. This is the way to remember. This is the way I remember it. Length is 1-dimensional, area is 2-dimensional, and volume is 3-dimensional. So an example is we have centimeters, centimeters squared, and centimeters cubed. So the exponents on the ratios are going to be A to the first to B to the first, which is just A to B, A squared to B squared, and A cubed to B cubed. So you should be able to see that we have a 3, a 3, a 3, and a 3. That's what we mean whenever we say everything is 3-dimensional. So let's do a couple examples. I want to do the evens together, and I want you to do the odds on your own. So try odds on your own. So number 6 says we have 2 rectangular prisms with a scale factor of 1 to 4. Find the surface area and volume of prism B, given that the surface area of the prism A is 28 square feet and the volume of prism A is 8 cubic feet. So that means a over b is going to be equal to 1 over 4. And a squared over b squared is going to be equal to 1 over 4 squared, or 1 over 16. And I also know that a cubed over b cubed is going to be equal to 1 cubed over 4 cubed, which is 1 over 64. So to find the surface area, I'll do that in red, I have to use this number here, 1 over 16. Because remember, surface area is square to square. Equals, I have to use this one here, 28 over x. Whenever I cross multiply it, I'm going to get x is equal to 16 times 28, which is 448. So x is going to be equal to, let me change that to red, 448 feet squared. So that's the surface area. So I'm going to do the volume in blue. I have to use this fraction. So it's going to be 1 over 64 is equal to 8 cubic feet over x. Remember, a is the smaller one. So whenever I cross multiply it, I get x is equal to 8 times 64, 512. And again, my units are going to be feet, this time cubed. Number 8 talks about two similar octagonal or octagonal prisms have base edges of lengths 14.25 and 9.5. So that means A to B is going to be equal to 14.25 over 9.5. Let's see if we can simplify that in our calculators. And we should see that'll be 3 over 2. So we have A over B is 3 over 2. So we're looking for the surface area. It says if the larger one has a surface area of 980.4. So the larger one in this case is on top. Whenever we're finding surface area, though, we have to square both things. So we're going to have 9 over 4. So we're going to have 9 over 4 is equal to the larger one. So since it says larger, we have to put it with the larger number. The larger number is on top. Divided by x. So then we just cross multiply it. And we get 4 times 980.4. So we get 3921.6 is equal to 9x. Divide both sides by 9. And we're going to get the surface area of the smaller one to be about 435.73. So we have 3 more problems to do on the back page. Number 10 says the volumes of 2 cones are 343 centimeters cubed and 625 centimeters cubed. So since we have volumes, that means we're going to have a cubed over b cubed is equal to 343 over 625. But before we do that, let's change this number to 125. The reason why I want to do this is because I don't want a decimal in the end. So since we're cubing this, I know that those are perfect cubes. There's a couple ways you can do this in your graphing calculator. One of the most common ways is to hit Math 4 and you type in 343. So that takes the cube root. You can also type in 125 or whatever number you want to take to the 1/3 power. So whenever you do that, you get 5. So anyways, the reason why we had to do the cube root is because we know that A over B is going to be equal to 7 to 5. And that is what the ratio of their radii are. So remember, think radii is equal to something centimeters. So you have to find out what it is, A to B. That's going to be our ratio. Number 12 talks about the lateral areas of two similar prisms, 400 and 256. So I have 400 over 256 is equal to A squared over B squared. That's because we have areas. Areas are square over square. So I need to take the square root of both of these numbers. So I take the square root of 400. I know that that's a perfect square, and I take the square root of 256. Again, a perfect square. So it's going to be equal to 20 squared over 16 squared. So A to B is going to be 20 over 16, which is the same as 5 over 4. We're asked to find the ratio of the perimeters. Their perimeters are in centimeters, or they're in inches, so it'd be in centimeters, I guess, because we have centimeters here. So the ratios are going to be 5 over 4. That's it. So the last one that I wanted to do with you was number 14. We have two spheres that have diameters 56 and 70. What are the ratios of their surface areas and volumes? So we have 56 and 70. That's equal to A over B. So for the surface areas, I want A squared over B squared, which is going to be, before I go there, let's simplify 56 over 70. We could do it the other way, but it's going to be a lot less complicated whenever we change it into a fraction. So the surface areas are going to be 4 squared over 5 squared, which is going to be a ratio of 16 over 25. And for the volumes, we're going to have 4 cubed over 5 cubed. So hopefully you remember your perfect cubes. I know as a general rule we wanted you to remember the first 5 perfect cubes. So 4 to the third, remember you have to hit that caret, or we could type in 5 times 5 times 5, that's another way, 125. So that's it. Again, like I said, try to look at the odds, see if they make sense to you. If you have any questions or weren't able to figure them out, please come to class prepared and have a great day.